Hello, in this video I explain how to calculate the mean squared displacement of atoms in your trajectory. This is most useful when studying the diffusion of particles under various conditions. However, you can analyze mean squared displacement of any index group in your trajectory. Here I will analyze the mean squared displacement of the atoms of one of my ligands, but you can apply GROMACS MSD, for example, to study the diffusion of ions via the ionotropic channel. The command line interface of GROMACS MSD is typical for GROMACS tools. You must provide the trajectory file, the topological binary input file and index file. Then you must also specify the absolute path to your output file of files. GROMACS MSD allows you to output the mean squared displacement of your selected index group as a function of type, and you can also output the per molecule diffusion as a separate file. As with most GROMACS tools, GROMACS MSD allows you to adjust certain parameters depending on your need, and in this case there are two params that you must adjust according to your trajectory params. The first one, dt, is your sampling interval, and it must be at least the time step at which you saved coordinates during your simulation. In my case it is 40 picoseconds. The second parameter, restart, defines how often the MSD calculation is being restarted with new origin point. This value must be at least the value of dt, and as a rule of thumb, the smaller restart value is, the smoother is the curve in your final output file. Now that we have finished MSD calculations, let's check the output. We will initially plot them using XM Grace and then check their content in the text editor. This curve describes the mean squared displacement of our ligand atom over the time of trajectory. If your selected index group contained more than one molecule, this curve will be the average mean squared displacement of your molecules. But in my case, my index group only contained atoms of one ligand, and therefore this is not technically the average MSD of molecules, but it's the MSD of my ligand atoms. And the second file will be empty because again we only have one ligand molecule in this index group. Now let's check the content of output files in text editor. In the first file, the x-axis or the first column is our time, and the second column or the y-axis is our mean squared displacement. And you can see units more precisely in the labels records. The second file will typically have per molecule mean squared displacement for the case of more than one molecule. Thank you for your time, and let me know if you have any questions regarding this tool in the comments to this video.